Hi, I'm going to be walking us through task 1.5 today since I'm not here, and I just want to make sure you guys are caught up, and I think you'll be okay because you've been given a lot of good information recently, so I think you'll be okay completing this. Now, good news is we're not dealing with dots, we're not dealing with blocks, but we are dealing with the chain email. Not necessarily good news. Some people get a little annoyed getting these, but good news is this is about a guy who's giving away ice cream. He's offering people a gift certificate for a free ice cream bowl worth $5 if you forward the letter to 10 people. After you finish sending the letter to 10 people, you get a nice little ice cream gift certificate. It pops up, and then you get to take it to the store and you get ice cream. It's pretty cool. So what we're going to do is we're going to try and figure out how much this email gets spread, because he said, he wants to help grow his business, but unfortunately, he might be giving away a lot of free ice cream. We're going to figure this out here. So, chain emails rely on each person that receives the email to forward it on. If you ever wondered how many people might receive it if the chain remains unbroken, we're going to figure it out. So on day 1, Bill starts by sending out the email to 8 of his closest friends. At that point, they forward it to 10 people. And on day 2, it is received by 80 people. And the chain continues unbroken. Now, as it says right here, we're going to assume it takes a day for the email to be opened, forwarded, and then received by the next person. So you might notice we've already got some key information here. They tell us about days and the number of emails sent out. So when they give us this information, it's always good to represent it somehow. And I'm going to go with a table. Tables are always a good way to do these things. Now, as I mentioned before, time is usually going to be your input. So I'll put days right here. And over here, I'm going to put people. So we know on day 1, it was sent to 8 people, 8 of his closest friends. On day 2, they each forwarded to 10 people, so by day 2, 80 people received the email. Hopefully you're noticing a pattern here. Now, if they send it to 10, if all those 80 people send it to 10 people, let's see, 80 people send an email 10 times. 10 times. Leads me to believe that we might be looking at multiplication here. We're already seeing 8 to 80 would be times 10. So we're going to do this again. And what do you know? We get times 10. And you get 800. Pretty big number. Now, one thing is missing. As we've talked about, one thing that's always important in these tables is an initial value. If you remember, the initial value is when your input is 0. We don't have an input of 0. But we know it's going ahead, getting to the next value. We're multiplying by 10 each time. So to go backwards here, I'll say multiplying by 10 will be dividing by 10. There are a couple of ways you can approach this. You can do 8 divided by 10, get yourself a decimal, or you can leave it as a fraction. I think for what we're going to do today, we're going to go with a decimal, because the multiplication involved will be easier if we use a decimal. So I'm going to go with a decimal. So I would do 8 divided by 10, and I know it's going to give me 0.8. So my initial value here is going to be 0.8. That's going to be pretty important. Now, let's see. It's asking me how many people received the email on day 7. There are a couple ways I can do this. I can go with the table method. Maybe some of you have already done this. Now, day 4, multiplied by 10, that would be 8,000. Now, the easy way to multiply by 10 just means I keep adding zeros. Day 5, 1, 2, 3, I'm going to add an extra 0. Day 6, add another 0. Day 7, I'm going to add another 0. Wow. And Billy took me away here. That's okay. Can I squeeze that in? Yeah, I can. Wow. Look at all that. That's crazy. So I went from 80 to 800 to 8,000 to 80,000, 800,000. By day 7, 8 million people have received this email. So all I did was I used a recursive formula here. Hopefully that rings a bell. I knew my previous output would be multiplied by 10 to get to where I'm looking now. Or next, as we said. Now, if you remember from yesterday, if we wrote this in function notation, when we see previous output, we're going to replace that now. We're not going to write previous output out. We're going to write f of x minus 1, which means previous output, times 10 gets us to where we are now, which we represent that now with f of x, the output we're looking at right now. So again, this is our output now. And this is our previous output. So all I did was I took my recursive expression that I wrote out here and I just replaced it in function notation. Like hopefully you were doing on last night's homework. Alright, so I'm going to scroll down here now. They're asking me how many people will receive the email on day N. Explain your answer with as many representations as possible. Well, I just wrote a nice recursive formula here, so I'm going to write recursive. And I'm just going to transfer that over. F of x minus 1, which means my previous output, times 10 equals my output now. And I'm going to go with a dot instead of the extra multiplication. So look, I have a nice recursive formula. I want to write an explicit one too, because they told me to write it in a few different ways. Now, let's see. It's going to take a little bit of work, but we're good at this. We've been doing great at this. I go up to my table. I notice it's increasing by multiplication. If it's increasing by multiplication, that means I'm going to have an exponential function going on here. So I know f of x is also going to equal something times something to the x power. Because my input is going to be my exponent when I'm dealing with an exponential function, like we've reviewed. Right, now I got to fill in some values. Now I notice my rate of change here. It's getting multiplied by 10 each time. Since it's being multiplied by 10 each time, I'm going to plug that in right here in front of my exponent. And now, if you remember, same thing with linear and exponential functions, you always want to start with your initial value. Now, if you remember, we calculated that initial value in the table up here. I even colored it in green for you. Isn't that nice? My initial value is when my input is 0. In that case, my initial value will be 0.8. So I'm going to go down here. I can plug in that 0.8. And I have myself an explicit formula now, or explicit function. So I have two representations. I think that's pretty good. I could also use that verbal formula I wrote up here. I can just copy and paste that. Gotta love it. Copy. Paste. Previous output equals now. So I have a few different representations. That's pretty good. You guys might have come up with some different ones. Maybe you drew a graph. You could do that as well. Graphs are awesome. Graphs are really good. And in the case of this, we know that a graph would look like a curve, because exponential functions always look like curves. So let's just write it out like that. Boom. And this would be day. And up here would be, let's see, it would be how many people. Do I have room for it? I think I can squeeze it in. I love new ability, guys. You can just squeeze stuff in. People. Love it. And just so I'm going to tag that initial value right here of 0 and then 0.8. And I have a nice little graph that shows me. So I got 4 different representations. Chances are you might even come up with some different ones. Who knows? But that's what I'm going with. Alright, so now I'm going to go down to question 3. If Bill gives away a Super Bowl that costs $4.95 to every person that receives the email during the first week, how much will he have spent? Now, a week is 7 days. So we figured out earlier that after 7 days, on day 7, 8 million people received it. So I'm going to go down here and figure out how many or how much money you would spend? Well, I'm just going to have to do some multiplication. 8 million times 4.95. Now, I've seen people in the past do this. They do multiply all those zeros out. They get these columns going. I'm going to show you something that might be helpful. Just worry about your non-zero values. I'm just going to deal with these. I'm just going to multiply those and watch what I do. I'll do 4.95 times 8. Do it out here. 5 times 8. 40. Carry my 4. 76. Carry my 7. And I got 39. Okay. So now I'm looking at, okay, well, 39.60. I don't know. Something doesn't seem right here. I have a feeling it's going to be spending more money than that. Now, here's where our extra zeros come in. I'm going to take those zeros I didn't deal with right here, my 6 zeros. I take my answer, and I'm going to move my decimal. Want a loop there, not a line. I'm going to move it over 1, 2, 3. Why is it not giving me loops? I can try it again. 1, 2, 3, 4, 5, 6. I have all these empty spaces. Guess what I can do with my empty spaces? I'm going to plug in zeros. 1, 2, 3, 4. All these empty spaces are gone now. And guess what? My decimals moved all the way over here. So now I have a new value. 39600000. Now, if I throw in my commas, I can tell you, oh my lord, Bill just gave away $39 million worth of ice cream. Well, $600,000 worth of ice cream. I hope Bill's got a big business because he just gave away a lot of ice cream. Why would he do this? Well, maybe he's hoping that these people who come in with these free ice cream certificates are going to bring some friends who might buy ice cream along with them. You know, might help him build this business, but I don't know, Bill. I think you're going to end up losing some money. So that is task 1.5. I figured I'd walk you through it, and I hope you did it along with me. If not, you can always rewind the video, pull it up right along next to it, and do it along with me, because we're dealing with exponential functions here. We're going with how we can write it explicitly as well as how we can write it recursively. All right, good luck doing this.